Hello, class. You're welcome again. Today is supposed to be our last lecture, unless something happens. So I will begin with discussing the homework 5 and just make some comments because so many people have been trying to reach me. I've explained to you in class, I will not pick your calls. I won't pick calls from members of the class. So stop calling me. And if you have any questions now, you can ask. I will give at least 15 minutes at the end of this class for people to tell me what their problems are, and I will do the best I can. So, but please don't call me. Okay, so what are the matters that arise that we need to deal with in this lecture? Number one, we're going to do homework, look at homework 5. And as I said, this is the last lecture, but we may arrange one more tutorial before exams if you request for it. The last time we arranged a tutorial, my information is that you were not ready for tutorial and you didn't ask any question, and there was not much that could be done. So, but if you need a tutorial class, we will make an arrangement to make that happen. Examinations and grading for the course will be discussed today. I will revisit the issue of API programming, Fusion 360, and artificial intelligence. I will talk about licensing issues with Fusion 360 and alternatives. And then we will finish with discussing more about Python scripting and another package called FreeCAD. And some of you may already be aware of that. That is a CAD software that you don't need any license for. It's freely available for download on the internet. So those are the things I want to talk about. But like I said, there are other specific issues that affect individual students. If you have issues like such, please reach the chat room early. I will first of all look at the questions in the chat room. Then after we have exhausted that, I will take new questions from anybody who wants to talk. This is just a review of what we already have. Homework 3 is about the six-cylinder engine, which you have already submitted, and I gave each person a unique firing order. And that unique firing order is specific to an individual. So you cannot just simply copy another person's program and come and submit it. Similarly, the homework 4, there is I wanted you to do a manually completed volute, and I gave you the loft profiles. The number of loft profiles differ from student to student, and I gave you a formula to get your loft profiles. I hope you all understood that method. If you have difficulties with it, let me know. Homework 5 is supposed to be the complete turbine. So that means that you have the turbine, you have the impeller, its blades, and the inlet and outlet manifolds. All those things would be made to complete the turbine. My original thought is to encourage you to make you program that in Python. And I was going to share my own code with you, but time didn't allow us to achieve that. So what I would do here is that you'll still get your full marks if you do your complete turbine, even if you don't program it. But if you have already known how to program and you can code it, I will encourage that. You'll get extra marks, but you can get full marks if you just do your turbine properly. So programming is not required, but it's encouraged. It's not required because we didn't spend enough time discussing programming, and therefore we cannot require that from the students. The complete profile, the complete turbine will look something like this. You see that there are elongated pipes at the inlet, which is from here, and the exit, which is from here. Those elongated inlets are necessary when we want to do engineering analysis of the turbine. We want to do analysis of the turbine, we need those things. If you don't do those things, you cannot analyze them. I will explain to you why that is so. So you cannot just do a turbine and finish. If your goal is to design a turbine, then for every change you make either in the volute shape or in the blades of the impeller or on any other parameter you vary, you want to see how that affects the performance characteristics of your turbine. In the olden days, we used to have physical turbines in our labs, but the non-physical turbines that you can actually program on your computer is actually far better for design. And so the fact that this is one advantage, this three-dimensional 3D modeling graphics actually the modeling closes the gap between the haves and the have-nots. You go to a university, they have a very good lab. Your university doesn't have a very good lab. And even then, the uh, virtual laboratory that we can create with this 3D solid modeling is exceedingly powerful. And I will just give you a hint of that as we go on. So I want you to know that your technical graphics learned at this level is just stage one out of about 4 or 5 stages in actually designing anything. And this turbine is a good example of it. I will just show you a hint as to what we now do with the drawing after we have drawn them accurately in this class. I'll just give you a hint of it. You will immediately see that we can't do much until you get to 400 or 500 levels, because it's only then you would have learned enough theory about fluid mechanics and some other things that will be called upon before you can use the software like Autodesk CFD or Fluent or Flow or ANSYS, any of those things that are actually dedicated to analysis. Even COMSOL Multiphysics can also do fluid analysis or design analysis for you. But your drawing is just your technical drawing is just the stage one of it. And that's why it's good for us to master this very early in the day. What happens to most people is that it is when they get to using that COMSOL Multiphysics or CFD that at that time they now start doing 3D solid modeling, which is very terrible. The time to do it is now. You do these things now and you are used to it. So anytime you want to analyze an engineering model, you already know how to get it into the graphical form before even starting anything, and you can do that well. And also that gives us the emphasis of this course. You can do many things with Fusion 360. You can be an interior designer with Fusion 360. You can be an artist. There are several, you can be an architect. You can be a civil engineer that is doing building information management. And so many things, people can use it. But for this course, our emphasis is in technical drawing. And the goal is to be able to produce engineering artifacts and objects that you can later analyze either as fluids or solids or using elasticity principles, plasticity, viscoelasticity, and all those ones. So when you do all those courses and you have the correct software, you will now be able to analyze the things you have done. That is the emphasis of this course. It's not that we don't know you can do rendering, you can create very nice pictures, you can make the sheet of the skin of a sports car, which interests many of you. All those things can be done. But we are emphasizing specific things here. So just know. This particular one, I did this turbine here, writing 500 lines of Python code. And I can still share that code with you, though I will show you where you get that code after this course. I don't want that to disturb this course. So changing the parameters can give different impeller orientations, as you can see later on. There are so many things you can change on the fly once you write code to do it. It is not every drawing you do that you can put in code. The drawing must be simple enough. The turbine here is a simple drawing. But if it is an elaborate design, you may not be able to write code to do it. But it turns out that the kind of things we analyze in engineering are usually simple things. We remove excessive parts and all those ones. There are specific critical areas where failure may occur that we want to make sure that they are designed very well. So those are usually simple. And the beauty of writing Python code to achieve those things is the fact that if you now want to change, you want to do sensitivity analysis, you want to be changing parameters, you don't have to draw again. You are just going to change the parameter and you have a new turbine. and that is it. And there is nothing for you to do again. Nothing can go wrong because you have already put in all the variabilities that can arise, and you are just going to be changing some figures, and you get new things. I will dwell more on that shortly. For example, to do an impeller, I just want to start with a very simple impeller. A simple impeller, all you do is you can just draw a circle, extrude it a little bit, and get the plate, and then you can do two or three arcs of a circle like this. If you do two arcs of a circle, this particular one, all the dimensions are there. You do two arcs, and then you extrude these arcs up, you get these shapes. You get this shape, and then if you do a polar pattern replication along an axis, in this case, I just chose three. So I'm sure every member of this class know that the way I got 3 blades here, I could have got 10 if I wanted, just by doing a replication of 10. So it is only the first one that you really do. The others are just given to you using pattern replication. Pattern replication is the key here. So I'm sure everybody in this class can do this now with a very short order. So this is something you can all do. Now, if you put that now, if you cut the volute that you have done, and you now link this to it using joints, you can use a revolute joint between the volute and the impeller, and you get this. So with this one, you can now rotate it. You can rotate it inside the system, and it will rotate, and all those things. And then if you now cover it up with the extension of the pipe here and the lid to cover it, then you have a simple turbine with a simple impeller and the volute that we have spent some time trying to draw. So that is a very simple thing. So now this is another one. This one is obtained using Python scripting. But even in the Python scripting, I just want to show you some salient aspects of it. You will see that at the edge of the blade, you will see this 3-dimensional spline. There's a 3-dimensional spline that is coming here. Fusion 360 doesn't have any difficulties in drawing spline, whether in 2 dimensions or 3 dimensions. In fact, when you are programming, all you are going to do is that you are going to programmatically generate the coordinate points of the spline. And it doesn't worry whether you do it in 2 dimensions or you do it in 3 dimensions. It doesn't care. It's going to put a spline on it. So you can see all these dot dots, all these dot dots you have here now actually constitute a 3-dimensional spline. So whereas on the face plate itself, you have a 2-dimensional spline. And when you want to do it in Fusion 360, you only need to allow 3-dimensional splines. If you allow 3-dimensional objects, you will get a 3-dimensional spline. There is a setting that you can use to make that possible. And then what happens here is that, unlike in this particular case, all you did is that in this particular case, all you did was that you just extruded an arc, because everything is just a true extrusion. But by the time you get to something a bit more complicated like this, you have a spline on the plate of the blade. You have another spline at another. You have another spline at the edge of two circles, and on the top circle, on the top disc, you have still a third spline. So what you are doing is that you are lofting the spline on the base plate to the spline on the upper plate, and you are using the spline at the edge as a guide rail. So those 3 things will give you a shape like this. And it is interesting to see that you can do all of this and achieve it programmatically. So when you achieve it programmatically, there are several things that you can therefore do. So this is Python scripting parametric drawing that you have here. This is the result. It shows the sketches, splines, and sketching planes. So these are the sketches are these two circles are the sketches of the plates. There is a plate down, which is a real plate of the impeller, and there's a plate up, which receives the top profile of the blade. So it is on the top profile of the blade that you do the spline that takes the top profile, and then the bottom profile gives the bottom spline, and then you extrude one to meet the other one. And when you extrude one to meet the other one, you can have this kind of shape. And if you just change the orientation of the top spline with respect to the bottom spline, you can change the way, whether the thing is straight up, like the extrusion case, or bent to the left or to the right. And there are several examples I will show you of that. So when you create the code using Python, when you create the impeller using Python code, you can vary the number of blades, the blade tilts, the blade profile, and more controls can then be added. Okay, for instance, these are two examples of results from the same code. You will notice that in the left impeller you have 7 blades. I mean, is it 6 or 7? Yes, there are 7 blades. On the right impeller there are 5 blades. How do you get from one to the other? It's just that you specify the number of 5 here and you specify the number of 7 in your program, and when you are running your program, and that's all. And then you can see that one tilts clockwise, the other one tilts anti-clockwise. The one that tilts clockwise, there is a particular parameter that is chosen that makes it tilt clockwise. And then if you negate that parameter, it tilts it anti-clockwise. So the beautiful thing about Python scripting is that these two impellers were created by the same code. You can change the thicknesses of the blades. You can change the thicknesses of the blade. You can even add the heights of the blade and so many other things. You can change the profile of the surface on which the impeller is resting. You can change the profile. Some impellers have flat profiles. Some have this type of profiles there. All these things can be done programmatically, and that's what I really wanted to show you. And that's why I was introducing the idea of API programming early. But unfortunately, I don't think we have enough time to consummate that here. But some of you are advanced programmers, so those who have done that, I don't want to kill your zeal. So if you have done it, submit it still and indicate that you went to indicate in your submission that you use code so that I can see your code, and I can also credit you with extra marks if you have done that. But the people who didn't do that will lose nothing because of just staying within the the scope of our classwork. So that is what I'm just saying here is what we have just already explained. And this is another something coming from the same code. All we did here is that we did a cut. We did a revolute cut of the blades in one way, in addition to what we did in the code. So that has this symmetric bulge, and then you can have these holes as you like. All these are the things you can do to your impeller. Why are we having all these different shapes and types of blades? Because these are the things that determine the characteristic and performance of the turbine. So most of the other things are basically straightforward, but you can change the behavior of a turbine by just changing the way the blades look, the number of the blades, the way they are arranged, and their sizes and their orientation, and so many. So that's why the design of a turbine is really the design of the turbine blade. Most of the things, small as the blade is, that's what really controls several things in the turbine. So if you want to create the blade, you can create the program the blade geometry. But let me just show you another example of how you can do a lofting with the least amount of effort. For instance, let us say on the bottom plate you just made a spline. On the top plate you can even do a straight line. By the time you loft using the surface, if you use the surface workspace of Fusion 360, you can loft one line to another line. If you have not done that before, you better try it. So if on one surface you have a spline, the other surface you just have a straight line, you can loft one to the other, or you can have a spline on both, or you can have straight lines on both. You can try all these things and see how they work. So when you after you have got it, you have something like this. This is what you have when you loft the spline to a straight line. You have something like this. And now Whether it tilts to the left or the right depends on the orientation of the straight line. You can just change the straight line. If you change the straight line, you can see that you can tilt the blade to the left or to clockwise or counterclockwise as you choose. So that is it. So once you have done this the skein of the blade, what is left for you to do is to thicken the blade. Like these are two blades now. One is just the sheet of the blade, this the profile of the blade, and then this is the same. These two pictures are giving you exactly the same blade. One is thickened, the other one is not thickened. So the top one is the ordinary one. The lower one is the one that has been thickened. So those are things I'm sure you can try your hands on Fusion 360 and you can see that you can loft one line to the other. That is not the way I did the one in the program. In the program here, I actually did the profile of the spline body on both levels with their dimensions, and then I lofted one profile to the other using the guide rails. Now the question is, which one is better? Well, the one where you did do the profiles is more, you can control more stuff because you may not want your blade to have uniform thickness. Most often, turbine blades, fan blades, they don't have uniform thickness. So you cannot control that if you use just the surface and you thicken it. You have to take, you have to, if that's what you want, it will be better to do profiles on both plane, on both surfaces, and then loft them one to the other one. So that is this one. Well, this is an example of, this is the kind of the code that coded that the code for this one is what I have here. The essential part of the code is what I have here. So we created two object collections, and then one is for a spline, the one on the bottom plate is for a spline, the one on the top plate is just for the line. So there are X, Y, and Z. There are only 2 points. Because if it's a straight line, you only need 2 points. If it's a spline, you can get as many points as possible, depending on what you want to achieve with your spline. So you can look at this code. This is the logic for thickening. You can do that easily once you have done it. And don't forget that you could even do this thing to this point, to the point up here, and then you can now finish the rest manually. The beautiful thing about API programming is that you can do API programming to a particular extent, and from that point on, you can do manual work till the end. So now I want to show you this one. In this particular case, we have done the blade profile, as you can see. Now we created, we used an annulus to create an annular sphere, cylinder at the center there. And then I have this other profile here, which is going to give the top of the top of the plate. So you can revolve this and then join and then use it to join the this one is this one, the top of the plate is done by revolution, whereas the blades are done by pattern replication. So the two, using the two together, you get the result. This result, the result here is done using the two together. You see, the revolution of that top plate is like this, and then the pattern replication of the blades is like this. And then when you do the two together, you have this result. So, okay. So you revolve the profile, and then you get this result shown here. Now, this is an example of what then happens after you have done your drawing. This is beyond this course, but I just want you to have an idea of what we do with this kind of things after we've gone through all this trouble. You can see here that I list 5 steps in analyzing the design of a turbine. The first step is you create the graphical model. Creating the graphical model is what you can do in Fusion 360, FreeCAD, or any other CAD software like you have. So once you have finished that, you now prepare the fluid body by creating the moving fluid and rotating region. You do that either in the Fusion or in the computational fluid dynamics software. What we mean by that is that the entire, for the purpose of analysis, the entire inside of both the volute and the impeller must be, the impeller itself must be completely submerged in water, and the inlet as well as the outlet must be full of water. Because one thing you will notice, one thing you will know when you study fluid mechanics in your later years is that in fluid mechanics, you have to have fully developed flow. So you cannot have partial water and air or whatever at any point. Everything must be completely fully developed before you can do any analysis. So that is, so this again, I cut this thing through using a section analysis facility in Fusion 360. And that is something you need to know how to do, because I can ask you for a section analysis in your exam. And if I ask you for a section analysis, all you have to do for me is to go to the drawing and then create, there is a thing there to create section analysis. There's a button or a drop down menu, and then you just choose the profile plane, usually X, Y, or Z axis, or a construction plane. And then you can pass the section analysis. That will give you what will happen if you take a cut. If you were to take a cut through the object, how the inside will look like. That is what we call section analysis. So this is an example. So the second thing is to prepare the fluid body. The next thing is to enter the simulation data, boundary conditions and everything. Then you will now solve. You can use, usually it is finite element or finite volume or a combination of both to solve the differential equations that arise using CFD software. You are not doing the solution yourself. It is the software package that will do the solution. And then after that, you interpret the results, which is called post-processing. You can interpret the result. You can get graphs and all those things. What happens is that normally when the impeller begins to rotate, the rotation of the impeller creates a low pressure at the middle of the impeller. That's what sucks in. That's what sucks in the fluid, whether water or whatever other fluid. It sucks it in, and the continued rotation throws the water centrifugally outwards, and then as it's thrown outwards in that motion, the velocity is increased, and you can use the shape of the volute to increase the pressure. So the velocity is increased. You can reduce the velocity and get the pressure. Using Bernoulli's equation, you can see that for a moving fluid, you can reduce the pressure and increase the velocity, or you can reduce the velocity and increase the pressure. So when you do that, so that is how a centrifugal pump works. You can go on the internet and check and get some videos to see how centrifugal pumps work. What I'm saying here is that don't just take these things as a drawing. In engineering, the engineering course you are doing, we are not just drawing for fun. We are drawing so that you can connect it to your engineering training. And you see that the drawing there is for you to be able to create engineering objects for analysis. That is the reason we do it. I am not saying you should restrict yourself to that. Who knows? If you do interior design and that gives you money, and that's good. If that can help you to survive in this difficult land, that's great. If you know how to use it as an artist, that's also good. Then if you know how to do rendering, that's the thing about it, is that there are up to 20 different things you can do with the knowledge you have, all of which can actually help you to survive and so to succeed in future life. But I'm just telling you that our goal, the goal of this course, is for you to create engineering objects. I'm not saying therefore you shouldn't learn anything else, but you should not forget what the goal or the particular course is. So now I told you, let us go back to the beginning. I told you that today I'm going to talk about homework. So the homework, homework 5, I've told you, you do not need to use program to supply me the full turbine. I have given you a hint as to how you can get your impeller, the turbine's impeller, how you can get that done. So where we are now is for me to tell you how the homework will be graded, how your exams will be done, and then after that, I will discuss API programming and licensing issues. So let us go to page 22 now, where I now decide to be talking about exam. Make no mistake about it. The turbine we are discussing here is coming in your exam. So what it means that people who are careless, either by not doing if you are careless by not doing the homework, or by copying the homework, or by being careless about it, you are going to be punished twice. You are going to get 0 or a very poor grade for your homework, depending on how serious your carelessness is. And then because the exam is going to take that same drawing you have submitted, and I'm going to ask you further questions on it. So imagine a student who didn't submit the assignment. When he now gets to the exam, he's now trying to draw that thing from scratch. It definitely will not have, there will not be enough time in the exam to draw from scratch. That is why we are adopting this method. That's why most of the time drawing exams are not done in the regular way. But we can achieve the same end by letting you bring in your homework, and then because you've already submitted it, so and it is that homework that you need to continue with. If you start with something else, you are going to get failing grades. You must start with your homework. So that means that since this will come in the exam, it is important to you. We want you to do a manual design, and the number of blades should be determined by the way your assigned homework 3 was done. Because in homework 3, I told you to make a number of profiles, but the profiles you make dependent on your matric number. If you don't remember that, go and look again. And if you did that homework yourself, you shouldn't forget. So in this case, I can say, okay, make the number of blades using that same method. That means that each person must do his or her own work. So how many blades you present will depend on your matric number. Now, I want you to submit your assignments as scheduled for full marks. That is, each assignment is carrying 10 points. So let us look at what happens to a student who did not do any of the 5 assignments. That means that type of student can only fight for 50%. So even if he passes, let us say he even gets 30, just look at the situation where the person gets 30 over 50. If you have scored 0 in the assignments, that is 30 over 100, which is still a failing grade. So I am advising you, and I'm pleading with you to do yourself a favor. Submit your assignment. Even if you are submitting late, you are going to get your marks reduced, but it is still not like you are fighting. I will show you now the submission rate of many students. There are students who didn't submit any assignment, no assignment 1, no assignment 2, no assignment 3. They have cheated themselves, in which case that right now they are only going to be struggling for 70 marks. Even if they pass those 70 marks and get 35 over 70, that is still a failure grade, because by the time you get 0, 0, 0 in 3 assignments and 35 over 70, you would think that's 50%. You should pass. You just find yourself taking this course again next year, because you still must submit your homework. So you are going to bring that homework apart from submitting, keep it, because you are bringing it to the exam. Each day delay in submission after the due date will reduce your mark at the rate of 1 mark per day. You bring your drawing with you to the exam. If you have no drawing, there is no need to attend the exam. Just go and re-register for the course next year. So there's no need. So, and I am saying that now, when you still have opportunity for a remedy. It is the same drawing you submit that will be graded in the exam. Your exam questions will ask for specific modifications. So what is the difference between the homework and the exam? What you know is that we will talk about turbine in the exam, but what particular question we will ask, you don't know. But you will know in the exam what I want you to do to the turbine. It is not something that is going to take a long time for people who have done their work. For those of you who have done if you have the turbine done by yourself, you didn't just simply copy somebody else, and you are so smart that I couldn't detect that. If you come to the exam and it's not your work, you are going to have difficulties in doing that, in doing the little things I will now ask you to add. And don't forget, in the exam, we are now watching you. We are there with you. You are not alone. So we will see whether you are doing your work or you are not doing your work. So that's the difference between the exam and the homework. The homework gives the basic spine of the question. The exam gives the details of the specific things that you have to answer. That is how the assignment and the exam are related. So when you say, where are we? Last time we were introducing the application programmers interface. As you can see that arrow on the left. But we are thinking of creation of sketches, bodies, surfaces, sub-assemblies programmatically at the project. No project. All the project you are going to do is to just submit your exams and to just submit your assignments. I'm not giving you any project beyond that. And then I'm not going to trouble you with creation of all these things programmatically because we don't have time to our advantage right now. But I'm not stopping those people who already started on it. They can submit, and I promise you, if you submit good stuff, you are going to get extra marks for that. I want to reward students that are working harder than beyond the call of duty. There are students like that, and I know there are. So, unfortunately, we could not meet the goals of this course in the API programming. I shall therefore not require API programming in the final exam. I shall also not require that you carry out the final homework assignment in programming. If you have done your own Python code, you may still submit for extra marks. The API, and the API and artificial intelligence. Since the last time we discussed, this is the last lecture, I've spent some time on API and AI, such as ChatGPT, Google, Gemini, and DeepSeek. ChatGPT, Google, Gemini, and DeepSeek. And I can give you my own findings. My own findings, that's just my own experience. And the API as well as the AI space is evolving. So this will not necessarily be the final word on these things. The summary is that, and for your information, I'm going to do a YouTube channel after this course to talk more about programming and creating technical graphics. There, I would say a lot about using API. So, and then I will be able to show you a place where you can download my personal code for your own work. I will supply codes in there will be codes in Fusion 360 and codes in Free, which I'm using now. It is possible. I have found that it's possible to use AI to accelerate your programming. AI is a very powerful tool and it can accelerate your programming. What I found is that when I was doing Fusion 360 programming without AI, I used to go, I was visiting the API reference manual a lot. What I discovered is that the AI already has access to the API reference manual. And therefore, if you have reached a point in your program and you are looking to write a small subroutine in a very tiny fraction and you do not really remember, imagine you want to do some filleting. You know how to do filleting in the GUI. And you now want to say, okay, how can I have these two edges and I want to fillet them. How do I do it? How do I write Python code to do it? You can ask AI to just write to you that when your question is that specific, the AI can be exceedingly helpful. But if all you want to do is that, AI, please do my work for me, yeah, it's going to give you some garbage, which is what you deserve. But so I found out that it is those who know how to program that can actually benefit from AI in programming. That's what I think. That is my experience. Because when I asked the AI to do things for me, it gave me codes that were not working, and it just used arbitrary data. But if I know precisely what I want and my information is accurate, I found this very, very useful, especially when I started using FreeCAD. I found out that the API was all known to the API was all known to the AI, which is fantastic. That means that I have less journeys going to manually read the API reference manual, and I can even get a fragment of code which I can improve on and get my code working. So AI can actually be used to advantage. So it is possible to use AI to accelerate your programming and Python scripting. However, you cannot simply tell AI to do your work for you unless what you want is trivial. You get garbage code that is likely unusable. If that is my own finding so far. Like I said, things can change. I have been using because my license for Vision 360 is ending, and I do not want to pay them $600 per year for that privilege. So I started learning some other some other graphics package. I will likely stop using Fusion 360 at the end of this course because they are not renewing my license, and we need to pay $600 annually to retain the privilege of the software. And I've depended on this software for 35 years. I've been using this thing since the days of AutoCAD in around the mid 80s. And so I like it a lot, but having been forced to seek other alternatives, I saw that a lot of things have evolved in the open source area that I had ignored completely. One of the several alternatives that give you that one thing that gives you free license is FreeCAD. There are many. I saw up to 10 different software packages, all of them having their own niches. There is Blender. There is I don't know whether Blender is completely free, but it has a free part. And then there is CAD, and I saw quite a few. But I like FreeCAD because FreeCAD is closer to my own goals. FreeCAD is made for engineering technical drawing. So, and then it's also completely scriptable in Python, which I like. It's the closest I see to Fusion 360 in the free area. If it is the commercial area, there are many alternatives to Fusion 360. There is SolidWorks, there is Solid Edge, there is Inventor, there is Pro Engineer. There are many, but all of them have their peculiar licensing thing. You see, the problem is this. Let us say you become very proficient in Fusion 360 and you are using it for your business after you have graduated. Autodesk will then ask you to pay fees. If you are doing Fusion 360 and Autodesk CFD and some of these things, what I read is that the fees can be as high as $25,000 to $40,000 a year, depending on what you are doing, and that prices people in a country like ours out of it, because we do not, even if you are making money, it's not likely to be big initially. At least it's not likely to be big enough to be able to pay their rent. So I choose to go to the one that is open source, and I will show you here some of the advantages and disadvantages of that. So one of the several alternatives that gives you free license is FreeCAD. It has a much higher barrier to entry and a steeper learning curve than Fusion 360 and other commercially licensed software. Now, FreeCAD and micromodels. One attractive attribute of FreeCAD is that it is fully Python. So there are several consequences of this. It has its own IDE, that is integrated development environment. You can make use of other IDEs than Visual Studio Code. So there are people who do not like that they have to use Visual Studio Code, especially people who have been programming Python already, and they already have something else they like. So when you move from Fusion 360 to FreeCAD, if you do, you will see that you are no longer restricted to Visual Studio Code, and everything you do is in Python. Even when you do your GUI, if you go and create a circle, it can give you the code that you have it generates a code that creates that circle, and you can put all those codes together and run them later as a macro. So if you like to gather those codes together, it will help you package them and run the macro. Advantage of that is that you can even use it to learn Python. You can use it to see how Python, you can see some of the activities you have and how Python is actually making those things to happen. So the underlying Python code can be scripted for you, and you can save it and later run it as a macro. Another thing about FreeCAD is that it is standalone and you can use it offline. You don't have to have an internet connection and all the things that Fusion 360 seem to impose on you. And number 4, it is faster, it is lightweight. Number 5, by the time you know it, you may find other attractive qualities in addition to its being free. Disadvantages of FreeCAD. I've told you some of the advantages, but there are disadvantages. FreeCAD has a very steep learning curve. I learned to use Fusion 360 very fast. And I usually, after somebody has been exposed constantly for a week, he should be using Fusion 360. I don't think, I don't even believe that a month is enough to be freely using FreeCAD, because there are so many, especially for somebody coming from Fusion 360, there are so many nuances and some things that work in a completely different way. So I always like to use the easier software because it expands the size of the students, the student class that can follow. I remember when I used to teach programming, I was teaching C++, and the number of students that were following me, very few. Later, we moved from C++ to C Sharp. I saw that the number of students that were enjoying it was increased. Then when we moved from C Sharp to Python, wow, the Python is so easy that virtually even students that are not even thinking of being programmers themselves, they can follow. So I like easy programs. That's my reason for Fusion, because some of you may be wondering, why Fusion 360? Why Fusion? Why not other things? It is the simplicity and the power that make us. So when you compare FreeCAD to Fusion, you see that FreeCAD is an immature environment. And that is a loaded word, immature. Let me just give you some of the things that you will see in an immature environment. Before we go to that, remember Autodesk, the makers of Fusion, have been in the business since 1982. FreeCAD started 20 years later. That age gap shows up it shows up frequently in the maturity of what they are offering. FreeCAD has more stringent solver conditions. You will discover that whereas Fusion 360 can change the color of your drawing when it is fully constrained, so also does FreeCAD. You will see the color of your drawing change when it's fully constrained. It will change to gray when it's fully constrained in FreeCAD, unless there are settings that can change that. What happens in Fusion 360 is that whether your drawings are fully constrained or not does not stop your solid bodies to be created. In FreeCAD, if you do not get your bodies to be fully constrained, it may work, it may not work, and you may just find that your drawing has crashed. So it's not as robust as Fusion 360. And then it has fewer options. For instance, if I want to create a circle, I can create a circle in Fusion 360 if I know the center and a radius or a diameter. I can create a circle if I know one line to which it is tangent and two other pieces of information. I can create a circle that is describing a triangle. I can create a circle that is subscribed inside a triangle. I can create a circle that is tangent to another circle and some other things. And if I just have those pieces of information, any one of them can be used to create a circle. So the options you have in FreeCAD are much more restricted. But when you are really good at it, you can still create all those conditions. But you must, by that time, you are an expert user of it. It's not for the faint-hearted or somebody who does not program and just dabbling into it. Sketching and 3D creation options are not as many and they are not as robust. A FreeCAD is much harder to set up fully. And I get entertained by people who write me, "Sir, my computer is not working." And I say, "Sorry, I don't know what they expect. Do they think I sell computers or what?" Some of you think I'm a dealer in computers, that I can give you another computer, or I will just come like a spirit and make your computer work. If your computer is not working, sorry, there's not much I can do. But FreeCAD is harder to set up. So those complaining now will have much more to say if it is FreeCAD they are using. I thank God that it is Fusion 360 I'm using. So I can only imagine the number of complaints I would have got if it was FreeCAD that we based this course on. And then FreeCAD is less collaborative in use. In Fusion 360, you can have group projects and everybody is contributing to the same thing. Now, I've finished on that. I'm now going back to exam grading and missing grades. Some of you students, you have sowed the seeds of missing grades. You've already created a situation where your grades will miss at the end of this term. Now, it may be deliberate. I have taught for a long time. That's why I'm retiring in the next few months. I've been at this business for a long time. I have seen students who will come into exam hall with no interest in doing the exam. They will write some rubbish on their script, and they will make sure that they sign the paper, they sign the attendance, and they will not submit anything. And they will come later and prove that they were in the exam, they signed, and the lecturer somehow lost their script. That caused a lot of confusion for me as a young lecturer. And I solved that problem more than 30 years ago. So if you think you can do that, Ojoro, for me, it's not going to work. I have solved that problem. And that is why I get all the identifiers I want early. And I know your last name. I know everything I need to know. If you do not supply all those things and you say things are missing, I will say it back to you that you deliberately did it. So by refusing to submit assignments, by never giving your name, your matric, or other identifiers, and then hoping that somehow you'll be able to create a case for free grades at the end of this course, you are misfiring. You are in the wrong course. It's not going to happen. You will have to earn the grades in this course. And any mark you get, you will know where the mark came from. And let me show you the submission details I presently have. For your interest, let me just show you. For instance, let us look at the first name here, Fowowe Sahid. Fowowe Sahid has submitted no homework 1, no homework 2, no homework 3. And the next 3 are exactly in the same club as him. And that's Jayola Adekomi. No homework. Oladipupo Kolaru has tried. At least he submitted 1 homework and didn't submit the other 2. So also the Oladipo. I can go on. That is how, this is just a report of your class that you can see here. I have this. So I am not going to be searching for anybody's assignment or anybody's mark. We will make sure that you will not come and claim you submitted what you did not submit. So that's why this work is being done before the exam, before the term ends, so that you can make amends. Those people who have not submitted homework have a choice. They have a chance. You can still submit homework 1, homework 2, homework 3. The only thing is that you can no longer be aiming at full marks. The full mark for homework 1 is 10, homework 2 is 10, homework 3 is 10. The maximum you can get, if you submit now, is 5. But that is still not bad, because you are still to bring that homework to the exam, and I can still ask you questions on that assignment in the exam. So if you do not submit at all, you are doing yourself a double disfavor. So better do something about it now. So I made this list available in these slides to help you. So if you have not submitted, you still can submit. Secondly, I have tried very hard to make sure that I get all the names for students. I give you opportunity to give me your first name, your last name, which is your surname, and any other names that you have. I spent 2 full weeks trying to get that from you, and I can see how everybody was just doing as they like. Until now, take a case like Babidele Oluwapelumi A. Babidele Oluwapelumi A, with all we have done, he still refused to give us what that A means. It's not that I need it for anything, but just in case there is any problem later on, I want your full credentials so that if there's anything to trace, we know where to trace them. And these are the matric numbers that we have right now. And if there is an error, you can go to don't call me. You can go to your class rep, and your class rep can send me a compendium of errors that are claimed from students. And then I will take a look at them, and I will act accordingly. If there's a genuine case, I would look at it. If there is if it's a tenuous case of somebody who just wants to just make trouble, I will just ignore it. But Bamidele Oluwapelumi, please let us know the meaning of the A in your name. That's not the end of it. There are at least two people who are members of this class, 240407507, doesn't have a name. But at least, even though it has no name, he has submitted one thing and has not submitted the other things. And 230407060 also has no name. And even though she has no name, she has submitted one assignment but has failed in the two assignments. I'm saying that for Sahid Babatunde, as an example, he has planned to fail this course. He has planned to fail the course. Why? If you have 0/30 in the first three assignments, then that means that even if you get 70, if you get a pass grading of 35/70, you still fail the course. Why do you want to do that to yourself? Why? Why? And your parents are struggling to keep you in school in these hard times. I think you should do better than that. So that is, I think, okay, there's still, for the submission dates, the first three assignments are already overdue. I mean, but students can still submit them to the class rep before August 13, and the class rep can collect that. And there is somebody that would put it and send it to me. So that's before August 13. I'm giving you that time of grace because I want it to be possible for you to submit do your final exam. Because if you don't submit anything, if you submit now, you get half the grade maximum, but you'll be able to still bring it to the exam and get your full grades in the exam. I mean, but if you don't submit, then when you come to exam, you are not going to get anything because it is going to be based on the assignments you have been given, that you have done. For each assignment, those who have not yet submitted will be shooting for 5 marks instead of maximum of 10 on each assignment. The total assignment grades for this course is 50 marks. So 10 times 5. That is 10 in 5 places. That's how we get those 50 marks. Remember that you must submit all assignments late or not before the exam. If you do not submit all your assignments before the exam, you have yourself to blame in the exam. And exams will be based on assignments. Bring your submitted work for further questions in the exam. Okay, so that is it. So what I want to do now is to open the chat room. Let's see what time we have. I will go to the chat room and I will be there. And those who want to discuss or ask questions can go. And let me just see whether, let's see, what about SolidWorks? Well, I don't use SolidWorks, but it is good. I mean, if you can get SolidWorks, get it. I don't use it personally, but I've had particularly nice things about it. The other thing I've used is Solid Edge by Siemens, also good. It is Bamidele Oluwapelumi Abigail. Bamidele Oluwapelumi Abigail, go and submit that to your class rep. I can, so that he will give me everything together. So it has taken you all this time to just tell us your name. Please, sir, assignment 1 is bench, right? Don't ask me any questions. Go and find out from the rest of your class what it is. Sir, I submitted assignment 1, but it wasn't ticked. Well, that is what you are claiming. I don't know. I don't know whether they don't like you. This profile for Volute you mentioned is referring to the number of lines in our Volute. No, it's referring to the number of loft profiles. It's not number of lines, number of loft profiles. Oh, you joined late. Welcome, very good for you. And what do you want me to do if you join late? I submitted assignment 1, but it wasn't recorded. Sir, I have really been active in class. Sahid Fowe, I don't know what that means. Why shouldn't you be active in class? Sir, I submitted my assignment, but I was not recorded. My file is still on the drive. I will submit all this to the people assisting me to check that out. And my student license using my school account is expiring in less than 7 days. I do not work for Autodesk, so I can't help you. Atana Alamotu. So, sir, the turbine assignment is different from the fan assignment. Is it possible to submit the last assignment on August 13? I'm giving August 13 extension for people who have not submitted the first 3 assignments. The other assignments, you'll be losing 1 mark per day when you fail to submit. So if you submit August 13, no problem. Instead of fighting for 10 months, you'll be fighting for 7 months. It's okay. It's okay. It's okay by me. It's okay by me. So I'm not going to give you the same grade as the people who obey the rules. No, you are not going to be treated equally. Well, I would, admin, I hope you can see all these comments. Admin, can you respond to me? Can you see Toby Owosheni's comment that he submitted his assignment? It's still on the drive, but it wasn't recorded. Can you see it? Admin? Is admin there?
Yes, sir.
Okay.
I can see you, sir.
The admin, Toby, the admin is going to collect this entire chat, and I will tell him to check the veracity of your claims. So, no problem. Yes, all of you who have complaints, you can type all your complaints here. We will take a look at them. So let's see. Well, is there any other question apart from assignment? If there are things on my assignment, type all of them here. We will take a look at them. What other free software? Well, I've told you all I know. You can go to the web, you can go to the internet and you find out. There are several. So it's just FreeCAD that I like. So I didn't look too much into. I studied some of the others, but there are others. Oh yes, I'm going to port everything. Emmanuel Odelano. I'm going to port everything that I've done in Fusion 360 that is useful. I'm going to bring everything to. FreeCAD. Yes, I'm going to do the coding. I actually like FreeCAD coding, and it is not as robust, but I like it because it also means that people will need to be taught to use it, which is something I want to do. I will have a lot of free time to do that. So all these crankshafts, all of them, they are coming back to FreeCAD. Homework 3 is 6-cylinder engine. Homework 4 is loft profiles with manually completed volute. Homework 5 is a turbine. There were 2 assignments before that. One of them was on the bench. I think the other one was on the. I've forgotten what the other one was, but I know the first one was on the bench. These are the 3, 4, and 5. Assignment 4 is the volute. Yes, it's around the cabinet. 1 or 2 are cabinet and the bench. Well, since there's a lot of complaints. Let us solve that problem here. Okay, let us say so. Assignments 2, 3, 4, 5. Forget about. Yes, I think. Okay. Yes, there was. I gave you an assignment on the. I gave you. Yes, I know I gave you. Okay, no cabinet. This is what Emmanuel has said is correct. I remember giving you bench, I remember giving you fan, and I remember giving you 6-cylinder engine manual volute. Yeah, that's it. Bench, fan. So this is, let's see, let me just be sure that everybody is saying it. Okay, I take that back. I take that back. I think Fatima, you don't know the difference between missing and mixing. Fatima, is it mixing you are trying to write or missing? Ibadan ni Fatima ni. Oh, Roma Jack. Did you see what the second one was? Fan. The second one was the fan. Bench, fan, crankshaft, turbine, and the complete turbine. Bench, fan, crankshaft, turbine, and complete turbine. Bench, fan, crankshaft, turbine, complete turbine. Well, I hope, let me just reiterate what we have said so far. What we have said so far are as follows. One, since there is a general confusion about assignment homework 2, I am letting it come in by the homework 3, 4, and 5 are fixed. We know them. But the homework 2 is the fan, because there is we haven't reached agreement as to whether I ask you to submit or not. Therefore, I'm extending the deadline of that to August 13. So if you have not done it, but you must get it done before the exam, because that is how I can ask you a question on surface modeling. So that's the thing. So that is, I want to be able to cover the things we have done. So I want your exam to be wide enough to cover all the things we've done. So I hope that is clear. Admin, since you are there, please take note of all the complaints students have made and liaise with Mr. Ogundero to be sure that all these things are checked, so that there's nobody who is wrongly punished. So check, bearing in mind how crafty some students can be. Yeah, just check. Some people may be telling the truth. So well, there are no further questions, so I think it is time to end this class. So thank you for your attention. If there is anything that I need to know, let me know it through your class rep. I think if not, if there's no other question, we can I can still wait a little bit. I think let me just wait 2 more minutes just in case. But put anything that is your problem on this chat. I will get it looked at. Anything you put on this chat, we will look at it. If you are lying, we will catch you. If you are not, we would rectify whatever error that we can rectify. But like I said, those who have not submitted their exam assignment, they can submit. They must submit before the exam. Submit before the exam. Even if you get reduced grades, at least you will be able to do your exam. Admin, please let the system be on for at least another 5 more minutes, so that you can take all the complaints there and we can look at them.
Okay, sir.